share.
Looks like it's recording to me. Yeah, we're good to go.
Okay, cool. All right. Welcome to the CMPT 125 exam review. I'm Cohen. This is
Sophia.
yeah. We are the Developers and Systems Club. This is really meant to be a kind of a low-key end of term event to just do some CMPT 125 exam questions and see what we can get out of it. First thing of note, this is what we're going to roughly go over today in the questions. We might swap a few around if there's anything that's interesting, but yeah. If there's one of these that is particularly interesting of note, because I don't know if we'll have time to get through all of them, just point it out and we can go directly to it. I'll try and do as much live coding as I can. Should be fun. All right, and then at any time, feel free to interrupt. This is largely about what you guys want to know, so I highly recommend just interrupting and asking whatever questions you have. We can go through line by line if you need to, and discuss. All right, so for question number one, what will be printed to the console if the following C++ code is run? The way it's going to work, the way it would work is the code below is what's being run, and then the user would type 125 into the console, hit enter, and then type final space exam space is space happening, and then hit enter again. Do you guys know what would be the output from this? Okay, so it's going to prompt us for an integer, 125, and then we'll put in a string. I'll just put 2 words. And it's going to put out just the first 2. So the reason this happens is because, for example, basically, if I put in two of these, the way it's going to work is it's going to basically skip the cins based on the space. So this is a problem that has appeared in previous final exams that has been known to trip people up. If I run it, let's see, I run it a second time, and it will still run final because basically it only reads the first space up to the space and then truncates it and splits it in, and the cins are ignored. Okay, so if we take the following function, char pointer foo int n, and we malloc its size, do you know what it's going to do? Basically, can you explain the functionality of foo based on what's happening here? And there's no wrong answer, so if you want to say it, by all means do so. Okay, so basically what's going to happen here is it's going to allocate the value of n, and then it's going to put one more on the end of n. The reason we need one more character at the end of n is, of course, to make enough space for the 0 at the end of any given string. So we always do one more. And then what it's going to do is basically in the very first position of the string that we put into foo, it's going to put a 0. And then based on that's the 0 which ends the string, and then it's going to fill it with n stars, basically. So based on the number you put into n, it's going to spit out that many number of stars and then return them as a string out as foo.
Oh yeah.
Okay, so that's basically a function which takes a string, a C string, so str in this case, and then you put another string in the other section of the bracket.
Yeah, just adding another string
And it
after.
connects them.
Just concatenation, yeah.
Yeah. So and then it puts it onto string. So the string in the first section is going to be appended right on the end. Okay. because we have enough space because we've already allocated it with malloc. And of course, once it's passed out, it's presumed that there is a pointer outside that it can be passed to, but it will have to be deleted afterwards. Okay, so we're gonna write a function that takes integer n and uses malloc to allocate an array of n integers. It's going to fill it with numbers 0 to n minus 1, and then return a pointer to the array. Okay, we're going to use C for this. So I'm going to move to the C file. Basic headers for.
How are you guys finding 125? Is it an okay path? You're like doing well on it? Yeah.
Okay, so first things first here is when we're creating the malloc, we have to provide malloc with the type we want to convert with. So when I write malloc here, the size has to be of a specific length that when we create the array, the malloc is of the right type. So in here, we obviously put n because that's what we've been given, but we're also going to do size of, and then int, because that's the type we want for the array. So we're making this many ints. So this is the amount of memory needed for an int, and then just that many number of them. And then do you know what type int pointer is? Because we're casting it from malloc. Int pointer here is basically just, it's kind of like an unsigned integer. Any pointer, you can put any word here, like it could be a char pointer, it could be a, I don't know, it could be a float pointer. It doesn't really matter. Anything you put in and cast as a type pointer is basically just an unsigned int, which contains a memory address. So what we're doing when we pass malloc into here is we're giving this little pointer here, the very first address of the malloc. And then, because we already know the size, we can go from there. So for int I equals 0, for a for loop, I is less than n. And then we're going to take the array, and we're going to use I to pass information into it. And we're just going to send I, because that was the statement in the problem. And now we need, of course, to pass the array back out so it can be used. And it's an array of dynamic length. So we're just going to return the first address to the array, since the array already exists in global space. And we're just going to pass the first address back out to the int pointer. So if I set up the main function, I'm going to specify n, and I want 10 of them, let's say. It doesn't really matter what size, obviously. And then in here, we're going to declare a pointer array where I want this set of 10 to exist. And I'm going to set this equal to the function we just created, and I'm going to pass n into it. From here, we can then, because we know the size of n, do a simple for loop. Say that it's less than n. And in here, we'll just print it, the type, which we'll have these labels. So there's a ton of different labels in C, but this one in particular is related to integers. And so we'll just print them all out, and then we'll free them. And return 0. So couple things to note about this. Can you specify what the time complexity is? For example, if we were going to describe this in big O notation, which you're going to have to do. Yeah, OF, because there's a single loop going on. And now the one question that would be is why is it not O to the N2? Like if we're just going based off of main. Because the for loops aren't stacked, it's still ON. Okay. So when we run this, we'll just this is C, so GCC demo. Oops, I'm missing rapid somewhere. It's just the C version. Who knows why? Okay, so that spits out all the numbers as per the problem. Compilation commands are an interesting subject. Basically, just they release a new standard of C every few years, and then the 17 on the end is just the year that standard was released. So 98 is pretty standard, but I can compile with year 17, and that just sets the version of C to the year that it was released. Okay, so linked lists. This is probably going to show up on the final. So if we want to implement a singly linked list in C++ and write a function to append a new node at the end, and then we'll just want to note the type complexity after. For this, I'll use C++. So in C++, we use IOStream for input and output instead of stdio. And just to make it simple, I'll put a using namespace std at the top. That'll stop us having to write std every time we reference a library. So the struct, which is connected to a linked list, is called a node. And inside of the struct is going to be an int related to the data. I don't have to use typedef for a struct. Struct is its own type. A typedef is an interesting subject unto itself. So typedef really generally is specific to like here's a typedef, here's an int, and then my own int. This is a new type I've created, which I could use if I wanted. Yes. It's okay. It opens really fast and it doesn't have any features. So that's why I use it.
You're gonna use VS Code more often once you have to like SSH into CISO. You're gonna have to like connect to the CISO computer from your home. So I just recommend using VS Code.
Yeah. I don't use VS Code, but I'm a little old-fashioned when it comes to coding, so I don't need all of the features, though maybe I do, because I make mistakes a lot. That being said, in here we also need we need to reference ourselves. So we're going to make a node pointer, which we can declare inside of here really fine because it's just a pointer. Pointers are always the same type. They're always the same size. They're just an address. Then we're going to need a function for appending. So we'll use the struct we just made and say append, and then we'll append just the address of the head of the root of the and then we'll put a value inside of it. Inside here, for appending, we're just going to put a node, new node, and then we're going to type, because we're in C++ now, we can use new rather than malloc. And then inside of the new, we're just going to put curly braces and the value, and then null pointer. So null pointer just lets us attach. So what these brackets do is they're referencing the struct called node, and we're attaching the value to data, and then null pointer is just lets us put nothing inside of node. So null pointer is an address, but it's just an address that's been reserved in your computer for no address, basically. They're technically the same thing, but a class just gives you more features for declaring what is a public and what is private. So structs don't have features for public and private access. So if you had a third-party library with some obscurities in it, they would hide like what you can use in the function. Like there's the code they use to do the computation and the code you use, and you could hide it all in a private and then give you a library without any head, without anything that's been precompiled, and you won't be able to see anything that's private. Structs don't have that. You can use structs inside of classes. They're kind of connected as a concept. Okay, so we'll just do an if statement here that looks if there's no head, because and then we'll just return right from here a new node. Because we just want to make sure. That way we can declare new nodes. And then now we need to handle the current. So what we'll do is we'll just go node and then cur equals head. And then we'll have to loop through the list. So we'll use current and then we'll point it into next. And then we'll equal current will equal the current section of the linked list, but we'll pass the next section in so that we can just go to it. So no need for curly braces because we're only doing one statement, and then we can just take the current, pass next, and then we'll just assign that to be equal to the new node. Sorry? Yeah, it's a singly linked list. And then just return the head. Okay, so when we're setting up the main function, to start the linked list, we're going to set a node. Oops, not function. And we'll set it to the head, and it's going to equal to the null pointer because we're in C++. And null pointer saves a lot of headaches. So for 4, we're going to do an int I equals 0. And then I is less than, doesn't really matter, but we'll say 5, I plus plus. And then inside of here, inside of the brackets, we'll type head equals append. And then we'll just pass the head and we'll pass I. Semicolon. Then we'll take the node and we'll take node and with the current node, we are going to set it to equal head. And then what we can do is we'll just go through and output all of the nodes. So while current, then we can just see out the current and then point it to the data so that we can express it. We'll just the space between. And then node, the temporary node is going to equal the current node. And then current equals current, but we're going to point it to next so that we can cycle. And then we'll just delete the temporary node at the end. Well, between each loop, I should say. And then we can just see out for good practice an end line at the end. The end line is not really necessary, but it could, in theory, be useful. Okay, so before I run this, can you list the time complexity? Okay, so the time complexity in this case, because we're running a node inside here, so it's n squared. Because by running append, and because we have this, now there are circumstances where you could not know what's in the function when you could just then say it's a given, in which case you could reduce it down to on. But because we actually know what's inside, then it's n squared. Um, I think this is the
It's
same.
basically the
See?
same without like moving it to a new line.
Yeah. Oh, yeah, I mean, I could just move it down.
Yeah.
This is the same thing. So if I run this, we're in C++, so I'll just go to CPP, and to avoid the last time problem, I'll just say we're using C++ 17. Oh, we're GCC, G++. So I don't know if your profs still hide all this stuff behind make files, but used to be, oh, what did I do wrong? Is this simple? Is that name a type? Note. Oh, I wrote note, didn't I? Where did I write note? Note. Okay. If I run this, you can just see it outputs the 5 nodes that we've created in the linked list. Okay. Any questions? So, sorry. Okay, so a while statement in this case is just it's just a measure of true or false. So all we're asking is while there is a next, and because this case exists right here where there might not be a next, so if next was a null pointer, it would just be false. So when it's false, it'll stop and move on to the next command. But while it's true, in this case, this is a true statement, while a next exists, then it will execute this operation. So no information is being changed by this statement. It's just a measure of true or false. Anything else? What's next on the agenda? Okay, QSort. This usually shows up on C 125 finals. So use QSort to sort an array of n integers and then show the required comparison function. So usually what they just do in the finals is make you write the comparison function on its own without any of the other stuff, but let's do what we can. Okay, we'll use C. Because QSort, there are other sorting functions in C++ that are much easier, so typically we don't use QSort in C++. Was there QSort in your guys' class? I don't know how I'm... Oh, so did you guys cover sort? You must have covered sorting algorithms, though. Okay, so here, actually, you know what? We'll skip this. If you just covered sorting algorithms, what we'll do is we'll go down. I have a question later on that might be more relevant for you then. Really, you don't did binary tree? Oh,
Oh,
that
you're
was
getting quiz on binary
ah,
trees?
lucky. I was okay. In that case, I'm running on old information clearly. Okay, right at the end, I have a little thing on bubble sort. Did you guys cover bubble sort? Okay, so there's a chance you might have to write bubble sort. So in that case, I'll use C and we'll just make a bubble sort real quick. I highly recommend just drilling this into your head because you may just have to write it verbatim into the quiz. I had to. Or maybe not, who knows? But can't hurt to make sure. So, okay, stdio.h, that's all we're going to need. Then we can just, I'll make a really quick print so we can view it. Print array. It's and then we'll just do a for loop inside that prints the array. Technically, you could use a size t for this, but I'm not going to. So plus plus I just reverses the operation. It does it implicitly. Okay. %d. Then we'll just print right at the end to break the line. Okay, so just basic print. Now let's write our bubble sort. So bubble sort is kind of like it's an O of n. Well, it's not necessarily O of n. It's a worst case scenario O of n function. So it's going to have embedded. It's going to have a function embedded in it. So basically, we're going to be writing bubble sort like this, and it's going to take an array and a value of int n. And then what we're going to have inside of it are basically two for loops. So there's going to be a for loop and another for loop inside, and then some kind of comparison that happens right at the bottom. So basically what we're going to do is we're going to go through and we're just going to start shifting things over. Whenever there's something larger, we're going to move it over. And then I will control that. Okay, so we're going to write I equals 0 to just grab the start, and then I less than n, but we're only going to do n minus 1 because we actually will never need to compare that value. Well, we'll need to compare it, but it's not going to not necessarily matter. And then inside the next for loop, we're just going to grab the other side. So we're going to grab array, and then we're just going to do, oh, no, I'll do this wrong. It's going to be int j equals 0. And then, well, j is less than n minus I. Oh, thank you. Minus 1. We don't need the last one. Then we can just plus the j at the end. All right, and then in the comparison, now we're going to check for which one is larger than the other, basically, because we're just comparing integers and sorting them. So we're going to take the j value, and we're going to say if the j value is larger than the array value of the next one over, so j plus 1, the minus 1 saves us from, so minus 1 will be called just from the plus 1. And then we're going to open a new statement, and then we're going to make a temporary integer. And we're going to say it's equal to the array position of j. So we're going to go through the array, grab the position of j, and then we're going to go through the array. We're going to take the value. We're going to say it's equal to array of j plus 1. And then we're going to move over, and we're going to take j plus 1, and we're going to set it to the temporary value. And now we switch places. All right, so this is bubble sort. This is all. This, if we, I guess I'll write the main function. It's main. I highly recommend just drilling this if you can. Yeah, of course. 12. It doesn't really matter. 6, 9, 0. That's 6 numbers. Int, and we can just grab the size of the array, then divide that by the size of array 0. And then that will just grab the total size of the array, no matter what size of the array. Then we can print if, and This is what's inside print array from the function we made earlier. Okay. And then we're just gonna, this is before, and then we're gonna bubble sort. And then we'll take the array and we'll put n inside. And then we'll just print it out. Then return 0. Okay. Just run that. We get the usual. Aha. Missing a signal. Okay, so inside before, but inside out. And double sort has shifted everything into the right place. Okay. Let's go back. Oh, any questions? Not necessarily. Okay, so for bubble sort, O of n squared is the worst case scenario. So if all of the letters were in the exact wrong order, it would take O of n times to move them all into the right place. However, on average, it's actually n log n. So it typically it's actually going to go faster than O of n squared. It depends a little on your prof. So if your prof wants you to do the usual, n log n would be the right answer. However, if your prof wants you to keep track of the worst possible case scenario, which is likely what they actually want you to do, it'd be n squared. Though the worst case scenario almost never happens when you have an array. Yeah, because it goes left to right, so it'll be largest number on the other side. In what you can do actually in that case is just you can make a correction for that and but there's no way of detecting whether it's in the right position from the get-go or not. So without increasing the complexity of other operations. So it would still end up being n2. Okay. What can we cover next? Okay, foo, this was linked lists. You didn't use qsort, and you don't cover binary search trees.
You haven't been taught binary search trees, or you're not gonna get tested on it?
Okay, I guess should I just skip it then? Or should we do a very quick?
Yeah, I feel it'll be useful for you if you do a minor on it. To just go through basic what is a binary search tree.
Okay, at its most fundamental, a binary search tree is basically like,
Well, it's a tree. If you visualize it, it's gonna be just you wanna pull up a picture.
sure, yeah. They look like this. And basically what's going on here is each node has 2 pointers. One which points to each side. You're probably better at this than I am.
I'll just go through
Yeah.
So binary search tree, these are nodes or leaves. We usually call it nodes, and these are pointers to it. So a binary search tree, usually that's there's different ways. Basically, it's how you go through the tree and ordering, I guess. Yeah.
Yeah.
So
They're kind of like an efficient way of storing a lot of data.
storing,
Yeah.
searching through. Basically, for you, I feel have you gonna pre-order, in order, post order traversal? No, right? So, just the order of if they say you want in order, then it's just numbering 25, 30, 35, 40. 45, 50, 60. It's just the different ways of like going through each of the nodes.
Yeah.
Um,
But I mean, if they haven't been taught, then maybe they're probably not going to be accomplishing much. But
you don't know what binary search trees in 125. How are you gonna do 225?
it'll be, yeah. Um, so I guess I could just show you what they look like at the very least. It is, so they're directly related to linked lists. So if I make I won't write out the entire thing, but if I do a struct node, what's going to be inside is basically your data for starters. So every node has a piece of data. And then inside the node, there's going to be a pointer going left and a node pointer going right, basically describing the tree. And then inside of here will be a function. So node, which takes the value and then compares it to the data of the value, and then left. Vector and right. This is C++ version. But anyways, it goes like this. And so basically it's just a tree basically. So it's a tree with data on the leaves, and traversing them is
Yeah.
it'll be important for your next class. So if you get the chance, look this up.
Link the value link list, but shaped as a tree. What is colon operator? You said it's a comparison function.
Sorry, what? Okay, so this is a comparison. So basically, it's just comparing the state of each of the values and then executing. This is what we call what's the correct term for it? It's not a lambda, it doesn't, you won't have to do this yet. It doesn't matter. But no, it'll show up in other areas, but basically it's just running comparisons. It's a lot like an if statement. Okay, beyond binary search trees. What is this one? Okay, yeah. Yeah, it's just n squared. Okay, do you know what STD vector is in C++? Because you guys have been learning C++, I'm correct, yes? Okay, so you haven't covered vector? Okay. Vector is just the thing, basically it's a dynamic allocator. So if I go to C++ and I include a vector, it's main. A vector is basically just a container. So you give it a type int, we call it an array, and basically what we can do with this type of array is just whenever we want to add something to it, is just type array and then dot push back, and then put a value in there, and then that will automatically increase the size of the array. So I can put like as many of these as I like. And then that'll just put it right on the end. So when you're using C++, you have access to a few more types. And one of the things you can get access to are just like features that don't require you to use malloc. So if I was to end the program right here and return 0, this is a completely valid statement. You don't have to do any deletes or removing. No. So you'll probably have seen STD and two colons in C++. Really all it's doing is specifying. So if I wanted to, what I could do is create my own version of a vector. So I could say name space vec, and then inside of here I could create a class vector. And then I could have my own vector listed here called vector, which maybe if it was a template, you don't have to worry about what these are. I don't think so. But the point is, you could have your own directly with the same name. And this would be a valid statement too. Okay, go on to the next problem. So basically this is just a thing on size t. So in C and C++, there is a data type called size t, which is available to you. It doesn't do a lot, but it is really useful for knowing the exact bounds of things. So inside of here, have you ever had to use size t in class? Okay. So size t is just so if you ever have, so say you were in int main and you were inside of you had an array. Um, uh,
Yeah.
size t. Okay, so size t is a type. So basically you can use a size t, and basically what it does is it just enforces the maximum size of a size t is whatever you can put inside of square brackets. So if I put n inside of a set of square brackets, say this was attached to an array, it would be the size t would basically just enforce that there's no negative numbers, there's no, and it can't go beyond the width of a possible array size. So when you're creating dynamic variables using malloc, one thing you can consider doing is using a size t to enforce the width criteria so that you'll never break your malloc. Yeah.
Yeah.
On the code? Right at the top? Okay, so do you know what? So, okay, so include is the preprocessor. So anything labeled with a hashtag is the preprocessor. And in C, there are a ton of libraries. These are, I can make my own. In fact, if I go here, I can create a new one. I'll put a comment in here. So, and then this can be lib.h. I can include lib.h with an include statement, and now that code exists wherever I put this. So if I wanted to, inside of here, put a void that is called this or something, and it returns. I could that is now a function that I can use here. There's a function here called something. And that's the same thing is going on with the ones at the top. They're just pre-included, which is why they have the little brackets around them. And CSTD-def just has a bunch of types, basically. So it's basically it's a list of type defs that are created by the header.
All right.
Yeah, sure. I had a recursion question. Oh, is it here? Who's in the binary search tree?
Oh, binary search trees. Well, like a popular recursion question are binary search trees.
Okay, well here, 1 second. I'll get you one.
Mhm.
Okay, here's what we can do. All right, we'll use C and we'll use stdio. Okay. So recursive questions, let's calculate a factorial. So some of the best, so recursive are basically, they're time limited functions. So they're functions that can call themselves, but there's some kind of criteria which allows the function to escape itself. So in a statement like this, we'd want to ask ourselves if n is equal 0 and n is equal to 1. So this is the start of a factorial statement. Then we'll return 1. And then we'll return n times itself, so factorial, n minus 1. So basically what's happening is when we set the number in n, it's always going to, unless it's a 0 or 1, it's always going to count back and until it's back down to 0. So this is basically a loop.
Are you more like, do you understand what recursion is, or do you want to like how to apply recursion in a question?
Yeah, I can understand recursion, it's like a function called itself, right?
Well, usually there's just two parts, the if and then.
Yeah, so
For example, if it's like a array or something like sorting an array.
Yeah.
It's already sorted or something, then it's a base case. Like a big example.
Okay. Maybe we could try something with this. We can use bubble sort in a recursive question. I'll have to write it out again, but let's do that. So we'll make a recursive version of bubble sort with that. Okay, so for recursion to end, we need to set a condition for the recursion to end. So we're going to do n equals 1, and then we'll just return there. This is a void. Then we'll set up the sort. So int I equals 0. Well, I is less than n minus 1, I plus plus. And if the array I is less than array of I plus 1, then int temp equals array I. And then of course we'll have to make the exchange. So when we're sorting I is going to equal the array I plus 1. This is not perhaps the best practice because we're not using malloc, but that's okay. It'll get the point across. Malloc just confirms that we have the right amount of memory. This function here does not necessarily confirm the amount of memory that's available, but it should be fine because you can put in the array itself and the length with n. So it doesn't guarantee it, but it doesn't really matter. So, and then in order to do the sort, because we're still doing bubble sort, we're going to need to call bubble sort again from within. So we'll just trigger it. And then because we have two conditions, we'll pass the array that we've been previously passed, and then we'll just do -1. So that way we can loop through. So we're starting at the largest part of possible value, and we're just sorting the other way this time. So it's going to go down the chain, and then start at the largest possible value, and then whenever it hits the end, it's going to return and go back up the chain and recall the previous function. So it's kind of like doing bubble sort but backwards. So if I trigger an int main function to start the program, we'll make an array of 43, 2, 3, and 5. And then we will grab the size of the array. That way we can always change the size of the array. And we can do that by just specifying the type, because any type that has brackets on the end of it is a pointer. So like specifying a pointer, this is also an address that we can manipulate. Or well, rather it's the first position in an address we can manipulate. And then we'll just grab the size. So we can just use one of the tokens for the size. And then we will call bubble sort. And then we'll pass in the base case. And then we'll just print it. And you know what we'll do actually is we're going to, inside of here, we're gonna print f sorted, and then we'll do, I'll do it in order. And I equals 0, I is less than n, I plus plus, and then this will be a printf statement. And then of course we use %d to represent numbers, integers, and then I, the end. And I'm actually just going to grab this little bit here so we can see what's going on right here. And we'll just say inside. We'll print the current end value of the array. Yeah, so this way we can see what's going on. So inside of the actual statement, we're going to show the current position once all the work has been done. And then, or maybe what I'll do actually is I'll do it after the bubble sort. We can see what it's like when it's been sorted. So because bubble sort is a recursive function, it's hard to know exactly what's going on as it's cycling because it's not a loop. Well, I mean, it is a loop, but it's a loop that's locked. So there's no actual for statement going here. Calling this function is going to cause n time complexity. Or in this case, this would run at probably n log n time complexity. So it'll run n times plus a bit for doing the sort. But because we can't see what's going on, I can't put a print statement beforehand showing the original. So I'll just show the operations as they are inside, though I have doubled it for some reason. Yeah. Okay. No, that's okay. So we'll show before, we'll show after, and yeah. Hopefully this works. GCC. Let's see. And then C17. Expected semicolon. Oh, this always gets me. Okay, cool. And then we can do ./a.out because that's the default name. Run it. Okay, so what happens with our array initial size 42, 2, 3, 5? These won't have to be sorted, but the 43 has to get over to the front. So when it outputs, it sees the 5, it sees the 43, and then it pushes it over. And then so you can see it only actually triggers 3 times, which is why we're not dealing with n squared complexity. So it only took 3 operations in order to move it over. That being said, inside of the bubble sort is still a for loop, so it's going to be n log n. So it's not necessarily that you have to calculate it, though you can do that. If we look at a big O chart, it's really about position. So if it's not constant, it's going to be log n. But if it takes longer than one loop to do n log n, or maybe it'd just be log n in this case, because it took less than 4 operations to get through. But there's a for loop inside, so it has to be more than. Okay, so what's going on is because the loop took three operations to calculate, that's log n, because that's not constant time, which would be log O1. But it is less than n because there are 4 positions in the array, and to get through all 4 would be n time. But it took less than 4 operations to get through the array. So it is log n. But the for loop is still being called inside of bubble sort right here. So this for loop causes the n operations to happen because we have to go through the entire width of the for loop for the comparison. But this is also being called 3 times. So it's log n additional times over n. So, no, continue. Oh, yeah.
It's their profits.
Yeah.
All bubbles or just without the brackets.
Oh, so you're asking why there's no brackets here? So basically it's just that we don't need them. We only need the brackets to declare the array. So basically what we're actually doing is we're saying that this is an array of size 4. But we don't need to specify that. We can just specify it here by putting 4 elements in. The brackets themselves don't actually mean much in this case. They're literally just saying that this is an array of multiple numbers, but we can actually just pass this around on its own without any issue. It's just passing the address around. Well, what we could do actually is, I'm pretty sure you could just make this a pointer. But if we do this, I think we have to pass the reference into here, like this. I might be, this might be above might not be true, but maybe that works. No, it doesn't like that. Oh, of course it doesn't like that. Maybe I actually don't do this. It might work this way. Yeah, this works. Yeah. So this isn't a pointer, it's still an array, so it's already in the address state. We don't have to dereference it in order to access the information. Yeah, because dereferencing it would be for function. Okay, so basically they're the same thing. So it can be a pointer or it can be an array of fixed size. It doesn't really matter. It's the same bit of information. And that's that this here is actually just a type called its width would be size t. It's basically just an unsigned long int. Yeah, so array is a pointer, so I can actually take I wouldn't do that here, but I can if I wanted to take the values of array, I could say I've seen, I think I put this in the thing. Sections on pointers. Uh, okay, so basically it's the same thing. It's just array is typically explicit. So what we're doing by asking for an array here is just saying we're really just telling the person who's involved that we want an array. It's not that we have to. Pointers work just fine. Um, it's just that when making a declaration like this, we don't necessarily know that that we're dealing with a pointer if we that we're dealing with an array if we put specify pointers, because pointers don't have to be arrays. Oh, it's 5:36.
Well, thank you for attending and thank you for all your questions.
Yeah. If you have any others, feel free to ask. I mean, we have a bit more time.
Yeah.
It's not going to take us a long time to get out, but if there's anything burning. Do you have any questions about like C and C++ specifically?
I'm sure you'll do fine. You seem like you know a lot.
I think I have many other questions.
Okay. Yeah.
Yeah.
Feel free to also message in the Discord server if anything comes up. We'll be monitoring it, so available to answer. Yeah. I'll send them in the Discord. I'll post it in the Discord.
Oh,
Oh, do I have uh poster? Uh, yes.
Oh, no, this is a picture I got at a hackathon. This is cool. I was like, yeah, what's this one? No, not that now.
Oh, I was completely ignoring the Zoom. Oops. Should I focus on C or C++ is all I saw. The answer is C is more important. Just for this course. C++, as soon as you're done with this course, C++ is more useful. But yeah. Yeah.
Mine was just all C because we only had a couple classes on C plus plus, and then it's fine.
Yeah.
Okay, you can always
Thank you.
like, you can like see code and that's good for me.